Okay, we are continuing on the Big Java book by Horstman, and we're getting to chapter 5, decision, part 2. We are comparing values with the relational operators. So we're talking about relational operators. We are comparing the Java operators versus the math notation. So most of you should know this by now. For the math operation, but we don't use the same thing basically because we don't have the keyboard for it. And then we are going to be using this for Java. So greater than, equal. You can pay attention that the equal sign is on the other side, not the beginning of it. Less than or equal. Again, the equal sign is on the right side. Equality, we need to spend some time on this. That's a special way of checking to see if two things are equal and not equal. Okay, so equal is for equality. When we want to compare it, so let's say we have floor, whatever. If I want to check the floor to see if it's equal 13, I have to use equal. So this is the way, of course, for some of you guys who are coming just brand new to programming, it's going to be a little time to get used to this. And so to check to see if my floor is equal 13, this is the way we're going to do it. 1 equal is assignment, 2 equal is checking to see if they are equal to each other. So a lot of people, when they start writing code, this is the common mistake that we all do, is in a set of equal, we put the 1 equal. So what this one does is going to put 13 inside of the floor. This is the assignment. And then if I have 13 here, the whole thing becomes 13, and that becomes a true statement all the time. So don't do this. Relational operators have a lower precedence. What does that mean? That means addition and subtraction is going to come first before the less than or greater than signs. So if I have something like if floor minus 1 less than 13, it's going to calculate floor minus 1 first, and then it's going to check it for less than 13. So this less than is going to happen later. So we are having greater than 13, less than the comparing, equal, it checks for equality. Again, not to put a sign equal. We're going to be using, this is very, very important, and we have to practice on that, and we're going to be talking about it. So for the string, we're going to use dot equals. We do not use equal, and we talk about it, why we are going to do that. For the double, remember double has a floating points, so decimal points can go for a long numbers. It can be, let's say, 12.00000005. or it can be 12.05, or it can be 12.00001. Because our computer system is in binary and numbers are in decimal is in base 10, computer is base 2. Sometimes the division makes the numbers, or even the storage of them, it makes the numbers not to be exact for the decimal precision points. So how do we figure that out? So yeah, if I do a square root of 2, if I do a square root of 2 and I print it, it's going to give me something like this. That's e to the power of minus 16. So that's the same as 10 to the power of 16. So this 4.4444 times 10 to the power of negative 16. That means it has 16 or 15 zeros before this and these numbers. So you don't even see it, 15 zeros and so on. So it's going to be very, very small number, but still it is there. So if I check for equality, it's not going to be equal to another one. So if I do this, if I take the r, which is this, the square root of 2, and then I multiply by r again. So I'm expecting if I multiply square root by square root, I should get my 4 back. And then I'm checking, I gotta get my 2 back, I'm sorry. So I take a square root, and I'm taking a square root multiplied by square root, it should give me my original number back, and I'm minusing it by 2, so I should get 0 in math. When you're doing the math, it should give you 0, but it doesn't do that in Java. The reason for that is because the leftover of decimal points we have at the end. So how do we fix that? This is called the round-off errors. So we never, ever check the double in this format. So how do we do it? So if we cannot do it this way, how do we do it? So one way of doing it is subtracting them from each other, the two numbers that we're comparing. We're going to put it as an absolute value, so we don't have to worry about the negative number. And then if this is so small that is smaller than epsilon, that is the 1 times 10 to the negative 14, then we accept this as equal numbers. So if it has 14 zeros, then we accept that as in a decimal point. So if it's going to be 0.14 zeros, then okay, that's fine. That's a small enough difference that we accept them as equal. So this is the way you're going to be doing your double equal to another double. Okay, this is a little tricky. So especially for those who just coming into the programming and Java, this might be a little bit tricky. So we are going to be using dot equals to compare two strings. Let's go over it first, and then we say why we're doing this. So we're going to be talking about later on about the objects. You have seen objects in chapter 2 and chapter 3. So whenever we have a class, we create an object of that class to be able to use it. So when we create an object of a class, that's going to go sit in the memory. And then we take the address of that object in the memory and we put it in the variable. So when we call new box, then it would give us create a box in memory and give me the address of that. So because Java is object-oriented language, almost everything except some primitive variable for our purposes, double and int and Boolean, everything else is object. So everything is carrying out an address. So if I have a string 1 and a string 2, this string 1 and the string 2 are pointing to a location in the memory. So if I'm looking for equal, equal, I'm looking to see if they have the same address in the memory. So for the sake of discussion, let's say my object is in address 1 million. So I'm not checking to see if my object is equal to another object. I'm checking to see if they are pointing to the same location. So my wife and I live in the same address, so both of us using the house address, they're pointing to the same location of the house. So for that reason, most of the time, I would say 99% of the time, when we're comparing two objects, we are not concerning if they are pointing to the same location. We want to see if they have the same content. So for the string and other objects, we have dot equals. As we're learning to build objects, we're going to learn more about how to put this equal inside our object to be able to use it. Next one is compare to. So we looked at the equals. Now we're going to be looking at compare to. So we can compare two strings together. So if they give me less than 0, that means if they give me -1, it means the string 1 is smaller than string 2. If it's giving me positive, that means the first one is bigger or comes after. And if they are equal, means they are equal. So if they give me 0, if I do a compare to, this is my first string. So name dot compare to name2 is going to give me 0. That means they are exactly the same thing. So how does this do? The way it does it, it goes to first character. It checks the first character first, then second one, then the third one. Now that these two, they compare all these things, and then it gets to this one. That means what? The second one is bigger than the first one. So if I do a string 1 dot compare to a string 2, means what? It's going to give me a negative number because the first one is smaller than the second. Now, if I compare these two together, so remember, we're going one character at a time. So we're checking C, they are the same. We're checking A, they're the same. Now we're checking this one, R and T. Because T is bigger than R, then the second one is going to be bigger than the first one. So that's what makes this cat bigger than cart, even though the size of the cart is bigger. Because we get checks one character at a time, the cat is going to be bigger than the cart, or it comes after it. So the way it looks up stuff is through Ascii table. Of course, we are using Unicode, which is extended Ascii table. Ascii table is 1 byte, Unicode is 2 byte. But I just want to look at the Ascii table because this Ascii table has some numbers that's going to be easier to follow. So this is an appendix to your book, and you can look it up on the web. I put the link on this one in there too. So you can see that, for example, if I look at capital A is a decimal number of 65, but lowercase a is 97. That means lowercase a is larger or bigger or comes after capital A. So if you have directory and you try to sort it based on the names, you can see the capital letters comes before lowercase letters. Another thing that you can see is we can potentially have our characters as numbers. These are not numbers, these are characters. So those are smaller than my regular characters. Or special characters, they are, I'm talking about $, %, and these are all smaller than my regular characters. So if I have this in a string, that string is going to be smaller than the other string. Just a side note about this and how does it work. So back to equal, and the talk that we had, that all the objects have a reference in the memory. They have the address in the memory. We do not move around the objects. We just going to get the address of it in the memory, and we're going to move around the address of it in the memory. So in this case, we are going to be creating a rectangular. Remember how we will do it. So when we're using the word new, it's going to go in the memory. Of course, for a string, it does it behind the scene. We don't see the word new in there. We just see it does it for us. So the new is going to create an object with these parameters. So it's going to use the class rectangular. It's going to create an object with these parameters. And then it's going to return its address, and it's going to put it in the box 1, wherever it is in the memory. 1,235,000, whatever it is in the memory, is going to return it in this. So if I just go print box 1, it's going to give me an address. Now, in here, I am assigning box 1 to box 2. The equal sign here is going to put this one in. I'm going to create another box called box 3. It has the same stuff in it, but it's a new one. So it's going to go create another location in the memory with the same content that the first one had, but it's going to be a different location. So we are checking for equality. So we are checking to see if box 1 is equal to box 2. We set them together. Where is my picture? This is my picture. So we have this in the memory. Box 1 is pointing to this object. Box 2 is pointing to this one. So when I'm using the equality, I am checking the contents of this variable, box 1 and box 2, which contain the address of this object in the memory. That's why box 2 is equal box 1, but box 3 is not equal box 1, meaning that they are not pointing to the same location. Now, if I want to check the content of them, I'm checking for box 1 dot equals, just the same thing that we did with the string. Now it's going to tell me if they are having the same content. So they have the same upper left corner, same width, same height. Remember, this is the top left corner, width and height. So we're using the equals to compare the content of the object. And majority of the time, that's what we want. We want to check two objects. We want to ensure that they have the contents that are equal to each other. All right, so let's talk about the null. So we said that when we're creating an object is going to return an address of the memory, and we're going to save that into our variable. Now, null is 0. In Ascii table, it's the first one in there. It doesn't have any value. It's null means nothing. So if my object variable is pointing to null, meaning that it's not pointing to anywhere. So if I have a residence, I am going to have an address of my residence. If, I don't know if I should say this or not, if I am homeless, then I don't have any particular address. So the address of a location is going to be saved in the variable, and then null means it's pointing to nowhere. That is not necessarily the same as null value in a string. So if I have a string equal null, that means it's pointing to nowhere. But if I have a string that contains null, that means it does exist in the memory. The actual thing exists, but it's empty, doesn't contain any characters. So we have to be sure that we can understand this and spend some time for it to really sink in. So we can check to see if our middle initial is null. That means I don't have it. It doesn't point to anything. Then I can just print the first name plus last name with a space. And if it does exist, then I can put that one in here. So remember, the null means it's pointing to nowhere. So we got to use equal to check for the null, not the equals. Equals is going to be checking for content. So keyword null is not the same as empty string. We got to be sure we understand it. And as you know, and I've been talking about this earlier, Java likes to use strings a lot. So learning about string manipulations is very, very important. All right, let's go over some of these things to see if we remember it. So if I have expression of 3 less than or equal 4, is that true or is it false? Is 3 less than or equal 4? That is true because 3 is less than 4. But we cannot put it this way. It's an error. Do you know why this is an error? Because equal less than does not exist. It should be less than or equal. Okay, is 3 greater than 4? Of course not, so it's going to return false. Is 4 less than 4? No. Is 4 less than or equal 4? Of course, that is true. Now, let's look at this one. We are doing 3 equal 5 minus 2. So this is going to come to the order of operation or precedence, operator precedence. So where are we doing? Are we going to do 5 minus 2 first, or are we going to do equal? So equal has very low precedence, meaning that things are going to happen on both sides before we checking for equality. If you're not comfortable with this, or you think it's not going to be confusing, you just put some parentheses around this one to make it easier to compare. How about not equal? 5 minus 4, or 5 minus 1 is going to give me a 4. And we are asking if 3 is not 4. Okay, so what's the problem with this one? What is the problem with this one? So first, I am checking to see 6 divided by 2. We're checking to see is integer divided by integer. So we're going to be okay. So 6 divided by 2 is going to give me 3 as an integer. I'm okay with that. Now I want to check to see if left side is equal to right side. But this is not checking. This is assigning. And it's trying to assign a 3 to a 3, which is not going to happen. You cannot assign something to a number. Okay, what about this one? We are saying 1 divided by 3.3 equal 0.333333. Remember, these can continue a lot. You can have potentially a lot of digits after somewhere that we don't even see it. So even though this logically makes sense, most likely it's not going to work because you're going to have some leftover digits. So that's where we're going to be figuring out how to use the epsilon, and we're going to subtract both sides. We're going to make it to absolute value, and we're going to check it to be sure it's going to be less than epsilon. So we're going to do this one. We're going to subtract it from this one, and then we're going to make absolute value of it. And then we're going to check to see if the total is less than epsilon. That means they're going to be equal to each other. Okay, what's the problem with this one? What's the problem with this one? I have 10, but 10 is surrounded with double quote. That means it's not a number, it's a string. I'm trying to compare a string 10 with number 5. Then we're going to have a problem. So you cannot convert a string to a number. We have to convert one of them to the other one to be able to check it. All right. So in here, we're going to get a substring of 0 and 3 from the tomato. Remember, 0, 1, 2. Your substring, you start with this number, but you stop right before the other one. So I'm going to get Tom out of this, and we are using the equals method to check if that's equal to this. Now, we're doing the same thing. We're getting the substring, but we are checking to see for equal Tom. This is a common mistake that we have done, or we will do it. We've got to be careful about it. So if this is the case, it's going to check the address in the memory that a string Tom is there. It's going to check the address in the memory that this substring has been created, and most likely they're not going to be the same. This is a different object than this one. So I know these are not going to be easy that you're going to remember right away. You have to come back to it. You have to practice, and you have to keep eye on it, and then eventually you're going to learn it. So we're going to go through some self-check. Again, pause it, go through it, take a pen and paper, write on it, or you can do it on the computer, but don't use your IDE. When you use your brain to do these things, to be sure that you understood the materials we covered. So it's asking if A is 3 and B is 4, which one of them are correct, or they end up to be true, which one is going to be ending up to be false. Next one is going to say, what is the opposite of this? Again, you can pause each one of these to go over it. What is the error of this one? We just talked about it a few minutes ago, so hopefully you remember. So we are asking the user to put Y to quit. So we want to check to see if it's 1. How do we test it? We are reading a string from the user, and we want to check it to see if it's Y. That's where we're going to put it in here. Again, put a pause on it and write it down. So how do we know if something is empty? Give us 2 ways of doing it. What is the length of my S if the S is empty, or if it's space, or if it's null? So we're going to check to see which one of them are actually correct way of doing it. It can be synthetically correct, but it might be logically questionable. So go through this, again, put a pause on this, go through this on a piece of paper, figure it out, and then we talk about it in class. Okay, that's going to be the end of part 2. I'm going to put a stop on it right now.